Okay, here's number 26. Starting with this, we're going to use our table menu on the calculator. So we're going to enter this function right here, 2 times the square root sign. So I hit second and the x squared where it says the square root in blue, and then I put the x in there, close the parentheses, hit second, and graph to get my table. And it's asking for the domain values of 0, 1, 2, 3, 4. So my x values 0, 1, 2, 3, and 4. Well, at 0, we're at 0. At 1, we're at 2. At 3, or at 2, I'm sorry. At 2, we're at 2.8. It says round to the 10th. At 3, we're at 3.46, so I'm going to round that to 3.5 because it says round to the 10th. And at 4, I'm at 4. Okay. 27. Using your calculator, sketch the graphs of the following functions. Identify the domain and the range. So once again, we're going to go to y equals. Clear out whatever's in there. I'm going to enter negative. Whoops. Let's go here. So here, I'll go back here. So I'm going to hit negative right here. And to get our absolute value, we hit math. We go over to number and hit choice number 1. That's the absolute value of 2 times x. And close that parentheses. And then it says sketch the graph of the following function. So to sketch the graph, we need a table. So I'm going to hit a table menu. And I'm going to just write it down here. Here's my x and my y. I'm going to say negative 2, negative 1, 0, 1, and 2. Negative 2, I get negative 4. Negative 1, I get negative 2. 0, I get 0. 1, I get negative 2. 2, I get negative 4. So now I'm going to graph this. At 0, 0, which is right here. That's the one I graphed there. And then I'll graph negative 1, negative 2. And negative 2, negative 4. And going on the positive side, I graph 1, negative 2, and 2, negative 4. And then we should use a nice straight edge to graph that. I'm going to freehand this one. Nice straight line. That's our absolute value. Looks like a V, upside down V because it's negative. And domain and range. The domain, how far left and how far right. Well, domain is going to be all real numbers. We can shorthand it like that. All real numbers or all real numbers. Range, how high and how low. So this graph only goes up to 0 and it's less than 0. It keeps going down. So range is going to be y less than or equal to 0. Number 28. We're going to go to our y equals, clear out whatever we have in there, and we're going to enter this function here. So I hit my second and get my radical sign up there. X plus 2, close the parentheses. And we are going to hit our second and table. So I'm going to put my table on here, x and y, negative 2, negative 1, 0, 1, and 2. At negative 2, I'm at 0. At negative 1, I'm at 1. At 0, I'm at 1.4. At 1, I'm at 1.7. And at 2, I'm at 2. We could choose some other values if we want, but that should be good enough. So I can say negative 2, I'm at 0. At negative 1, I'm at 1. At 0, I'm at 1.4. At 1, I'm at 1.7. At 2, I'm at 2. So maybe we want to take a look at this one on the graph to see how it looks. So we hit graph, and it looks like it's square root function. Takes off from here and goes like this. Out. So my domain How far left and how far right? Well, it stops right there. -2, right? So x, and we have -2. Where are my x's? They're going to be greater than or equal to -2. How high and how low? Well, it starts at 0. So y and 0, y is going to be greater than or equal to 0. The y values are greater than. This keeps going up. And we didn't check the graph on this other one, but we could do that really fast if we wanted to. So that graph looks the same as that first one, 27. Okay. Last page. So the school district makes tables that pairs number of letters in the student's first name and the numbers of letters of the student's respective school. So Stagg, Andrew, Sandberg. The table includes data from all schools in all three districts, all students in all three schools. Tell whether the pairing is necessarily a function. Explain your reasoning. So let's just make a chart. Here's the number of letters in your first name. So first name, and here's the number of letters in your school. So if your first name was John, you have 4 letters, let's say. And let's say you're at Stagg. So 1, 2, 3, 4, 5 letters at Stagg. Well, could there be a Mike? 4 letters at Andrew. 1, 2, 3, 4, 5, 6. Okay, we have x values that are repeating, so no, it's not a function. And once again, if we come up with one example, so no, and there could be the same name student, or a student with the same number of letters in their first name at more than one school. So we could have a John at Stagg and we can have a John at Andrew. So no, not a function. 30. A coach makes a table that pairs the number of letters. So here's number, letters, last name, and jersey number. So let's say your last name has 5 letters in your last name, Jones, and your jersey number is 1. And let's say somebody with the last name of Smith, they have 5 letters and their jersey number is 2. Again, we have input that has different outputs, so where we repeat the input. So no, this is not a function. No. And answer, reasoning, there could be a last name with the same amount of letters but they have different jersey numbers. Once again, we come up with one mistake that, or one example that proves it wrong, counter example that says it's not a function. So last two, 31, and 32. Compare the graphs of negative absolute value x minus 3 plus 4 to the parent graph. What transformation occurs? So it flips, then it shifts 3 units to the right, shifts 4 units up. That negative out there flips it down. Insides is opposite, left or right, so this -3 shifts it 3 units to the right, and then the +4 shifts it 4 units up. Alright, last one, 32. So this one, it doesn't flip, and then this is going to shift. Inside the parentheses shifts left or right, and it's opposite, so it shifts 5 units left and 2 units down. And that's it. Good luck on the test tomorrow.